Problem 150. This problem is being taken from the 9th edition textbook. A pressure gauge connected to a tank reaches 500 kPa at a location where the atmospheric pressure is 94 kPa. Determine the absolute pressure in the tank. Again, we need to look at our model. So this is our model. We have a tank, and this tank is connected to a pressure gauge, and this type of gauge is usually referred as the Bourdon gauge. If Bourdon gauge is being used, meaning that this is taken as a P gauge. And then it can be seen that this tank is located whereby the atmospheric pressure is 95 kPa. And this is a positive value of Pg, meaning that the absolute pressure inside here is greater than the atmospheric pressure. So next, we need the formula. The formula to get the value of P absolute is P absolute is equal to P gauge plus P atmospheric. And if we look right here, the homogeneous of unit, this is in kPa, this is also in kPa, meaning that we are going to have the answer in kPa or in kilopascal. So just add it up and do the analysis, the calculation. So that is your calculation, and that is your answer. Always remind that you must look and check, always look at the unit, whether the unit is tally or not. If not homogeneous, then you have to get the right unit being used. Problem 156. The basic barometer can be used to measure the basic barometer can be used to measure the height of a building. If the barometric readings at the top and at the bottom of a building are 675 and 695 millimeter mercury respectively, determine the height of the building. Take the densities of air and mercury to be 1.18 kilogram per meter cube and 13,600 kilogram per meter cube. So the concept that we are going to use is basically to look what is actually given by a barometer. If you look actually to a building, let's say this is our building. So this is the ground floor, this is the top. So when we put our barometer at the top, we'll get the atmospheric pressure at the top. If we take the same barometer and we measure the atmospheric pressure at the bottom or the ground level, this will give us the bottom value. What actually measured by the top? Basically the top will measure, the P atmospheric or the barometer at the top will measure the height of the air at this location. Let's say this is H top, whereby if you measure the bottom, this will be the height at the bottom part. Remember that we are measuring the atmospheric pressure using barometer, but if we measure using air, So actually this will give us the air height at the bottom and the air height at the top. So if we have the formula, rho is equal to, the pressure is equal to rho GH. Pressure is equal to rho GH. If we use the rho for air density, and if we use the H for air, and we know that the pressure is the same whether we use air or we use mercury. So in this case, the P can be substituted as the P atmospheric at the top, and also the P atmospheric at the bottom. So in this case, the HP and the HT, bottom and top, this will represent the height of the air. And if we have the HB minus the HT, what actually we have is the height of the building. That is how we use a barometer, which determines the atmospheric pressure to get the height of the building. Same goes if we have an aeroplane. Let's say we have an aeroplane at a certain height. Compare with the sea level. This is our sea level. Usually we measure at sea level. So if we have a barometer right here, we could get the P atmospheric 1, which is at the sea level. If we have the barometric meter or barometer in the airplane, then we get PATM 2. And the reading, what we do, the reading we equate as the rho for air, G and H for air. In this case, air at point 2. And this is also P equal to P atmospheric 1 is equal to rho for air, G, H for air at point 1. This value we get from barometer, mercury. So what do we have actually? This height, sea level. This is the H from here to the last element of air. Then we get here H air 2. Right? And then from this point up to this point, we are getting the H air 1. And if we subtract both of them, actually what we have is the altitude of this airplane, which is equal to H air 1 minus H air 2. This is how we get the height or the altitude of a moving aircraft by using the barometer concept. So based on that concept, then we could solve this problem 156 to get the height of this building. So this is our building. So at the bottom part, we have the atmospheric pressure at bottom, and top part we have the atmospheric pressure at top, and this will give us the H top and H bottom. And we have the H value is the height of the building. So this is the formula that we use by using the barometer, using the mercury as our manometric fluid. And for air, from this equation, we have H top. And remember, that is our pressure that we got from the barometer. This is the pressure we got from the barometer at the bottom. We substitute that in the equation for rho GH for air. Then we have the height as 231 meter.